Okay, so notes 10 is over applications of quadratic equations. So remember, tomorrow we have test 2. Test 2 will be over notes 5 through 10, but there really isn't much of notes 10 on that, so I would primarily focus on notes 5 through 9. Okay. So applications of quadratic equations. So we're going to first look at some very basic applications, and then we're going to talk about the Pythagorean theorem, because that is where, at least for this course, where we would see the most applications. Okay. So starting with the first one, applications of quadratic equations, a lot of them look like the first one. And the first one is not really, I wouldn't consider it an application. It's more of, okay, here's a word problem. All of the math terms are in words. We have to convert them into actual numbers in the equation that we can solve. So it says the product of two consecutive integers. So first, we have to identify what it means by the product. So what would we be doing with those two integers? Not multiplying, right? So the product means to multiply. And then what does it mean to be consecutive? One after the other. So, and then when we're talking about integers, we're just talking about positive or negative numbers. So two consecutive integers. So we can say let n equal the first integer. Okay. And if we want to find the next one, the consecutive one, we would say let n plus 1 be the second integer. Okay. Which means no matter what number we plug in for n, the n plus 1 will always be the number after it. For example, if n was 8, then n plus 1 would be 9. Okay. Yeah, it could also be minus because it doesn't say what order, so it could be, yeah, the number before as well. So if this says the product of two consecutive integers, then we're going to take n and multiply it by n plus 1. That's the first part. And you don't have to use n. You could use any variable. You could use the variable x, y, z, any variable that you want. Okay. Then it says is. So if we see the word is in a word problem, we know we're writing what sign? The equal sign. Okay, so we're going to go equal. And then it says 14 more than 6 times the smallest integer. So I'm going to ignore the 14 more than, and I'm going to look at 6 times the smallest integer. In this case, what variable is representing the smallest integer? N. So how would I write 6 times n? 6n. And then I'm going to go back to where it says 14 more than, which means what am I going to add after the 6n? Plus 14. So I feel like the hardest part of this would be taking it from words and putting it into the equation. Because then from here, we know that we need to, since we're dealing with quadratic equations, have everything equal to what number? 0, just like yesterday, everything equal to 0. So before I start moving over the 6n and the 14, I can go ahead and simplify the left side by distributing the n. Okay, so I have n times n, which is n squared, and then n times 1, which is, good, n or 1n. You wouldn't have to write the 1, but I'm not going to mark you wrong if you do write 1n. Okay, then this is equal to 6n plus 14, and we want this entire side to equal 0. So what am I going to do with those two terms? Move them over. Am I going to move them over by adding, dividing? What am I going to do? Subtracting them over. Okay, so I have minus 6n and minus 14. which means I have n squared. And then what would this simplify to? N minus 6n. Negative 5n. And then I'm just going to bring down that minus 14 because I have nothing to combine it with, and then set that equal to 0. Okay. So now that we have taken our word problem, converted it to a mathematical equation, and then put it into a quadratic equation, now we're going to have to factor. And we would factor by doing what next? Good, a times c. And what is a times c? Negative 14. Okay, because remember this is a, b, and c. So multiply a times c. So two numbers that multiply to negative 14 but add to negative 5. Good, 2 and 7, but which one would have to be negative?
7.
The 7. Good. So this is 2 times negative 7, which gives us negative 14, and then negative 7 plus 2, which gives us negative 5. Okay, or 2 minus 7, which gives us negative 5. Okay, so then I come here and I'm going to rewrite this as n squared plus 2n minus 7n minus 14 equals 0. And then from here, what would be my next step? Not combine like terms. Good, factor by grouping. And I know it's factor by grouping because I have how many terms? 4. Okay, so factor by grouping, which means I take the first 2 and put it in parentheses, and then the last 2 and put it in parentheses, and then I need to take out a GCF. Good, a greatest common factor. So what would be the GCF for the first one? N, and when I take that out, I'm left with n plus 2. And then for the next one, if I want the parentheses to match, what am I taking out? Good, negative 7. And so I'm left with n plus 2. Okay, and I know I'm running out of space, so I'm sure you guys are running out of space. I'm just going to continue down here. Okay, which means I have what two parentheses? N minus 7 equals 0. And then my last step would be to take each parenthesis and set it equal to 0. So I have n plus 2 is equal to 0, and n minus 7 equals 0, which means n is equal negative 2, and the other n is equal to positive 7. Okay, but remember in the problem, it said, actually it didn't mention this, but typically after here, they would want us to identify those two integers. So what we found was the smallest integer, just n, which means what would we have to do to each of these two values to find the consecutive number? So remember up here when we said let n be the first integer, that was the smallest one, and then we said let... we'd have to add 1 to each of these numbers, which means our two answers could be negative 2 and what would happen if we added 1 to negative 2? Negative 1. Okay, that would be our first possible answer. And then our next one would be 7 and 8, because we would add 1. That would be our other possible answers. Which means when we solved this, there wasn't just two numbers they were looking for. It wasn't just, okay, n is equal to 7, so our answers are 7 and 8. We got two possible ones, so we would have to add 1 to each of them to get our two possible answers. So that means both of these fit the criteria of the product of two consecutive integers that is 14 more than 6 times the smallest. Okay.
Is that the answer?
Yes, what I highlighted is the answer. Yes. Okay. So I'm going to ask you this. What if instead of saying the product of two consecutive integers. It said the product of two consecutive even integers. How would this differ? And how would you determine that? Right? Let's say we still choose n as our first number. Okay, if we add n plus 1 every time, is it always going to be positive? Oh, sorry, even. Sorry, even. I meant to say even. Is it always going to be even? No, right? Because if I have n is equal to 4, what's 4 plus 1? 5. Is 5 even? No, so what would we have to add to our first integer to make sure that they are always even? 2. That would be the difference. So, again, hint, hint, right? Product of two consecutive even integers means our second integer has to be n plus 2. Okay. If you're going to remember anything from this notes, is this first problem. That's it. Okay. So then the next one says a rectangular sign has an area of 40 feet squared. That's supposed to be a little 2 up there, not a 2 there. If the width is 3 feet shorter than the length, what are the dimensions of the sign? So for these type of problems, again, they're the word problems, it's best to always draw a diagram, okay? So it says a rectangular sign. So I'm going to draw a rectangle. Okay. It gives me the area of the rectangle. Okay. Do you guys know the formula for the area of a rectangle? Length times width. So that's important to know. Okay, because we found that the area is 40 feet squared. Then it says if the width is 3 feet shorter than the length. Okay, so that means we don't really know what length is, so I'm just going to write L. But we know width is going to be equal to what? How would I write 3 feet shorter than length? Minus 3, right? But what? L minus 3, right? L is length, so length minus 3. Okay. Which means instead of using length times width in my area formula, I'm going to be using length times length minus 3. Okay, so I have 40 is equal to length times length minus 3. Okay. Then it wants to know what the dimensions of the sign are. So that means once we solve for length, we need to plug in that value to find width. Okay, how would I simplify this? This part right here.
You distribute the L.
Good, distribute the L. Okay. So what's L times L?
L squared.
L squared. So 40 is equal to L squared. And what is L times negative 3? Negative 3L. And since we have L squared, we know it's quadratic, which means we should have this equal to 0. So what am I moving over?
The 40.
The 40. I'm going to subtract the 40 over. So I have L squared minus 3L minus 40 equals 0. I just moved the equals 0 to the other side. It doesn't change the problem, but you could leave the equal 0 on this side. It's fine. Okay, now we have a quadratic equation that we can now factor. So how would we factor this? A times C. And what is A times C? Negative 40. And then two numbers that multiply to negative 40 but add 3 or negative 3? Negative 3. Good. We always carry the sign with us. So that was A, B, and C. Okay. Anyone have an idea of what those numbers may be? Good. 8 and 5 or 5 and 8. Good. Which one would be negative? 8. So negative 8 times 5 gives us negative 40. And negative 8 plus 5 gives us negative 3. So that's how I know that those are numbers that are good to use. So then I write L squared minus 8L plus 5L minus 40 equals 0. I expand my B term to go from negative 3L to negative 8L plus 5L. What's my next step? Factor by grouping. Okay, and I'm going to take out a GCF from the first one, and what would that GCF be? L, and I'm left with?
One L.
Good, just 1L, or L minus 8. And then if I want my parentheses to match, what's coming out of the next one? A 5, and I'm left with L minus 8, which means I have L minus 8 and L plus 5. Good, and then I'm going to equal them to 0. Okay, so I have L minus 8 equals 0 and L plus 5 equals 0, which means in the first equation I have L is equal to 8, and the next one is L is equal negative 5. So these are my two possible answers for length. But if I'm talking about a real world example, can you measure negative 5 feet in length? No. No, so can I use L equals negative 5? No, so I'm going to cross that out. I can't use that. Which means the only one I can use is L is equal to 8 feet. But it also wants us, good, it also wants us to know width, so we're going to have to subtract 3. So we know L is equal to 8. And then W is equal to L minus 3, or 8 minus 3, which is 5. So length is 8 feet, width is 5 feet. That would be our answer. Okay, so the big difference here is if we're dealing with a application type problem, it's where we have to start thinking if those solutions are relevant to our problem. So just like we said, we can't have negative 5 feet. That's why we crossed off the negative 5. Even though if we were factoring this normally without the application problem attached to it, we wouldn't matter if L was negative 5. Okay, so that would be an extra step to look into is once you get your answer, think back to the context. Does it make sense in context? Yes.
So is there ever going to be a case where there's going to be two positives, like L's, two positives?
Yes, it could be 2 positives. It could also be 2 negatives.
And then we could, in this instance, we're trying to measure the area, trying to find the length of it.
Yes.
So will we add both of them together, or?
If we got 2 positive, then that means there'd be 2 possible lengths, like 2 different lengths, meaning they could draw the rectangle in 2 different ways and it would still be a rectangle.
Do we provide both of those answers?
You would provide both, which means you would have 2 lengths and 2 widths, because you'd have to subtract 3 for both.
See.
Would it be considered wrong if you did only one of them?
Like if you got 2 positive, yes, you'd only get half points.
I have a question.
Yes.
Why did the minus 8 and plus 5?
Where did this part come from?
Yeah.
So when we set these equations equal to 0, I just added 8 over, and that's how I got positive 8.
Oh.
And then I subtracted 5, and that's how I got negative 5. Mhm. Any other questions? Okay. So then the next one, let me get this stuff. This was part of that last problem. Okay. It says a stone is dropped off a 64-foot cliff and it falls into the ocean below. So anytime you have these type of problems, you want to draw that scenario. So here's my cliff. Here's my ocean. And if I throw a stone off the cliff, is it going to just look like this? If you throw something in the air, think of a ball. If you throw a ball in the air, does it just go straight down like that? Or does it curve up, then go down? It curves up, then goes down. Okay, this is my stone. Okay. And then let's see, I'm making sure I have all my information here, and it says the stone is dropped off a 64-foot cliff. So I know this cliff is 64 feet. Okay. Then it says the height of the stone above sea level is given by the following equation, which means it's talking about the maximum height of when you throw it up in the air all the way down to the water. So this entire space right here is going to be the equation h is equal to negative 16t squared plus 64. Okay. So then it says h represents the stone's height in feet and t is the time in seconds. Find the time required for the stone to hit the water. Okay. So here, when looking at these type of problems, we have to figure out what is relevant to us. Okay. So we did label that this cliff was 64 feet tall. But notice they already added that height into the equation. So they already added the plus 64. So technically we don't need this information because they already gave us the equation for it. Okay. Then it's saying find the time required for the stone to hit the water. If the stone hits the water, what's the height of the stone? If the stone hits the water, so you throw it off the cliff, it goes all the way down and it hits the water, what is the height of the stone at that water? 0, right? 0. Because look at the problem. It says the height of the stone above sea level. Okay? Which means as soon as we hit sea level, that is height 0 feet. Okay? So if you get to these type of problems and you're not too sure what to do, okay, think about all the concepts that we learned, right? We learned that we take a quadratic equation, and in order to solve, we have to set it equal to 0. So even if I didn't draw my diagram or understand what the question was asking, I could still take negative 16t squared plus 64 and set it equal to 0. Because that's what we've been doing in all the prior notes, right? These applications are not going to bring in any new concepts. It's just reiterating the concepts we already learned. Okay. So then from here, this tells us that we need to try to factor this. But before we can factor it, we need to see if we can take out a GCF. And can we take out a GCF? What can we take out? 8 to
4? 8?
Is 8 the largest you can take out? 16. I was thinking 16, right? Because what's 64 divided by 16? Is it 4? 4. Okay. And then also, not only should I take out a 16, do I like the negative in front of my quadratics? No, I should take out a what? A negative 16. Which means I'm left with t squared plus 4 or minus 4? Minus 4 if I take out that negative. Okay. And when I do this, you should notice, okay, this looks very nice. I know how to factor that because that's simply what? What is it called? Perfect squares. Perfect squares, because can you take the square root of t squared? Yep, and can you take the square root of 4? And do we have a minus in the middle?
Yes.
Yes, so that means we can do perfect squares. So I would say off to the side that a squared, which is that first part, is equal to t squared, which means a is equal to t. And then b squared is equal to 4, which means b is equal to, because we take the square root of each of them. Okay. Which means we have negative 16. Okay. And then what would my 2 parentheses be? Good. T minus 2 and t plus 2. So I have negative 16. That was my GCF that I brought down. T minus 2 and t plus 2, because of the definition of perfect squares, tells us that I can simplify or factor t squared minus 4 into those two factors. Okay? But now I need to solve for t, and I would do that how? Equal what to 0? The parentheses, right? Because what happens if I do negative 16 equals 0? It wouldn't be 0. It would skip it because it's false, right? Skip it because it's false. So I have t minus 2 equals 0 and t plus 2 equals 0, which means the first t is equal to 2, and the second t is equal negative 2. But what does t represent in the problem? Time. Okay, can we have negative 2 seconds? No. So can we use t equals negative 2? No, we can only use t is equal to 2. So this one we would cross out because we can't have negative time or negative seconds. Okay, same with the length times the width. We couldn't have a negative length, so we cross out that value. So this one only has one answer, and that is t equals 2 seconds. Okay, so this is saying at 2 seconds is when the stone will hit the water. Okay. I would say these type of problems are the most common type of application problems when dealing with quadratics, especially in college algebra when they will start talking about maximum and minimum values. Okay, so I would say this is a skill that you would definitely be using in college algebra. Okay, when you take that. Okay, now we're going to talk about the Pythagorean theorem. Okay. And the Pythagorean theorem is a way for us to find a missing side of a right triangle. And that's most important here, is that we are looking only at right triangles. And we know they're right triangles because in the corner they form a 90-degree angle. And that's denoted by this box right here in the corner. That's a 90-degree angle. Okay, so if we have a right triangle and we are given two values, we're able to find the missing value by using the following equation. A squared plus b squared equals c squared. Okay, and notice how it denotes a and b. So a and b are the legs or the sides that are attached to that 90-degree angle. It doesn't really matter which one you label a and b. The most important one is the one that you label C. Okay? C is always going to be that diagonal line, and they call that line the hypotenuse. Okay, so A and B, the legs don't really matter where you put them. Hypotenuse, the C value, is the most important. So when we're asked to find these missing sides, what we're doing is we're using our definition of quadratic equations. So for the first one, like a very basic one, right, we're given everything in numbers, so we're going to have to try to find the missing number. So first what I would do is I would label my sides A, B, and C. So again, this is the most important one to label. The other ones don't matter. So this could be A and B. Or you could say this is A and B. It doesn't matter. Okay. And then in order to find my missing side, and so in my case A, because I labeled it A, I'm going to use the equation A squared plus B squared equals C squared. And I'm going to plug in my values. So A, I don't know, so I'm just going to write A squared. Okay, what is B? 6. So I'm going to write 6 squared. And then what is C? 10 squared. Okay. Then I would go down and simplify until I get A by itself. So a squared plus, what's 6 squared? 36. So remember, something squared means you multiply it by itself 2 times. So this is the same as saying 6 times 6. That's how you get 36. Okay, what about 10 squared? 100, right? 10 times 10 is 100. Okay, if you can't figure those values out, that's why you have your calculator. So I would simply practice putting in 6 squared and 10 squared into your calculator. Okay, from here I want to get a by itself, so what do I need to get rid of, or what should I move over? Subtract the 36. So I have a squared is equal to, what's 100 minus 36? 64. Yeah, you guys were close. 64. Okay, and then I want to get a by itself. So how would I get rid of that square?
Square root.
Take the square root. So if I take the square root of both sides, I get that a is equal to, and the square root of 64 is 8. And what units are attached to the sides? Feet. So that means the missing length is 8 feet. Okay. I want to make one note about this because it's not going to matter too much now, but it will matter in college algebra. So anytime you take the square root of a square, okay, we know that these cancel. Okay, we got that. We technically get 2 values. We get plus or minus 8. Okay. The reason for that is if you square a negative 8, or if you square an 8, will they both give you 64? Yes, so you're not sure what the original a value is. You're not sure if it's a positive or negative 8.
So we would make a equal plus or minus 8.
Plus or minus 8. In any other type of problem, the reason why we go straight to 8 feet is because it's application. Can we have negative 8 feet? No, so that's why we kind of just skip it in this application, but it's good to know that this is always plus or minus whatever the square root of that number is. Okay. Always plus or minus. Okay. Go ahead and try this one. Take a minute and then compare with your neighbor. Remember, the most important one to label first is C. Once you label C, the other ones don't matter. Okay, so as soon as you're done, compare with your neighbor.
Oh, because you didn't square it. Oh, wait.
Okay, so solving this, the first step, the most important step is to identify C. What value is C here? 15. So this is C, and then I'm going to go ahead and label the rest. It doesn't really matter what A and B are. Okay? Which means you could have your answer saying A equals or B equals, and it would still be fine as long as you get the same number. Okay, so I'm using my formula A squared plus B squared equals C squared. In my case, A is 9, so this is 9 squared plus B squared, that's what I'm trying to find, equals 15 squared. Okay, then I simplify. What is 9 squared? 81. Bring down my B squared. What is 15 squared? 225. And then I want to get B by itself, so what do I do? Minus 81, and I get B squared is equal 144. And how do I get rid of the square? Square root, so I take the square root of both sides, and I get B is equal to 12 m. What is m? Meters. 12 meters. Okay, and if this wasn't an application problem, technically B would be equal to what? Plus or minus 12. Plus or minus 12. Okay. Okay, so here was just more introducing that topic of Pythagorean theorem to you. Now looking at an application problem, typically application problems are in words, they're word problems, okay? Which means from the word problem, when we draw our diagram, most likely we're going to get a triangle because we're practicing the Pythagorean theorem. So it says a 13-foot board is used as a ramp, okay? 13 foot used as a ramp. So here's my 13 feet. Okay. If the distance between the top of the board and the ground, so that's this, the top of the board and the ground, is 7 feet less than the distance between the bottom of the board and the base of the platform, so that's this distance, find both distances. So it's saying that this side right here is 7 feet less than this side. So since we don't know anything about this side, let's go ahead and give it a variable. What variable do you want to assign it? A? Okay, so this is A. So how would I write 7 feet less than A?
A minus 7.
A minus 7. Okay, and technically, yes, would be equal to B, the side B. But I don't want to confuse myself and add in that other variable, so I'm just going to say A minus 7. Okay, so it looks like I have a right triangle, which means I can use the Pythagorean theorem. So A squared plus B squared equals C squared. And if it helps you, you can say, yes, this is B, but I don't want you to write B equals and end up putting it into our equation by accident. Okay, so A squared, okay, so A squared plus B squared, B is A minus 7 squared. Okay, so B was A minus 7, and then I squared the whole thing, is equal to 13 squared. Okay. So when I have something like this, A minus 7 squared, I'm able to rewrite this as 2 parentheses, because that's what that squared is telling me, that it appears twice. So I'm going to rewrite that as A squared plus A minus 7 times A minus 7 is equal to 13 squared. And again, the reason I'm doing that is because from here, I know I can simplify by doing what? How would I simplify these 2 parentheses? Not quite, not yet.
2 negatives equal a positive?
Okay, eventually we would get there, yes. FOIL, we would use the FOIL method. Okay, remember FOIL means we take the first term and multiply it in, and then we take the second term and multiply it in. So I'm going to bring down the A squared, bring down that plus, and then I have A times A, which is A squared, and then A times negative 7, negative 7A, and then I'm on the blue arrows now. Negative 7 times A, negative 7A, and negative 7 times negative 7, 49, positive 49. That's where that negative and a negative gave us a positive. And then let's simplify 13 squared. What is that on your calculator? 169. Okay. So now that we're here, since we see the a squared that tells us it's quadratic, which means we now have to make sure that this equation is equal to what number? 0. So what am I going to do with the 169? Move it over. So subtract 169, subtract 169. And then I have a squared plus a squared minus 7a plus 49 minus 169 equals 0. Okay, I have everything now off to the left. And then now I should look at everything on the left side and see if I can do what?
Combine like terms.
Combine like terms. So I have a squareds here. I have 2 negative 7a's. And then I have 2 numbers. So I'm going to combine each of them. So what is a squared plus a squared?
2a squared.
2a squared. What is negative 7a minus 7a?
Negative 14a.
Negative 14a. And what's 49 minus 169? Negative 120 equals 0. Okay, this is looking closer. This is now our standard form quadratic equation, which means we can factor this. But before we factor, we should always check what? A GCF. Can we take out a GCF?
Yes.
What number? 2. So if I take out a 2, I'm left with a squared minus 7a minus 60 equals 0. Okay, then I'm going to do the a times c method. So I have a is 1, b is negative 7, and c is negative 60. So what's a times c? Negative 60. And then my b value? Negative 7. So I need 2 numbers that multiply to negative 60 but add to negative 7.
Twelve and 5.
12 and 5. Yes, that works. 12 and 5. Which one's negative?
12.
The 12. So negative 12 times 5 is negative 60. And negative 12 plus 5 is negative 7. Okay, remember, if you couldn't think of that, you go through every single factor. So you do, okay, in order to get 60, it's 1 times 60, 2 times 30, 3 times 20, etc. Okay, you would just go on your calculator and keep dividing and look at all the positive the even values that you get, the whole numbers. Okay, so then I rewrite this. I'm going to bring down my GCF. And I have a squared minus 12a plus 5a minus 60 equals 0. So then from here, I'm going to do what? Factor by grouping and take out a GCF. So what GCF can I take out of the first one? A. So I'm going to bring down my outside GCF, right? And take out an a, and I'm left with a minus 12. What can I take out of the next one? A 5. And again, I'm left with a minus 12. Which means I have what 2 parentheses? A plus 5. And a minus 12. Bring down my GCF of 2. Set it equal to 0. And then my last step here is to do what? Equal them both to 0. So a plus 5 equals 0 and a minus 12 equals 0. Okay, which means I have a is equal negative 5, and the other one is a is equal to positive 12, and a here is representing a distance. So can I have a negative 5 distance? No, so I'm going to cross that one out, which means I can only have where a is equal to 12 feet. Okay, so I'm going to go back over here. Okay, we now know a is equal to 12 feet, and we have to find b. So what are we going to do with the 12 feet that we have? minus 7. So 12 minus 7, and that gives us 5. So we have one side is 5 feet and the other side is 12 feet. So these are our answers here.
God.
Wasn't that fun? This is nothing. Just wait. Wait till you take... No, this one's not going to be on the test. No. This is fun, though. Just wait till you get to college algebra. There's there'll be problems, or if you're going to take calculus, there'll be problems where I can remember one problem took up 5 pages, front and back. And if you mess up one spot, you got to do the whole problem over.
You mean like these pages right here?
Yeah, like a paper.
How long does it take you to do that question by yourself?
Like a minute, less than a minute. Of course, it seemed long because I'm explaining every little step, right? Once you get it, you're not going to, when you're doing the problem, you're not talking to someone else explaining the steps. You just are going through it. Okay. Do you want to try this one on your guys' own or do it together?
Do it together.
Together. Okay, so same concept. It says we have a 5-yard ladder that's leaning against a wall. So let's draw a picture. Okay, here's our wall. Here's our ladder. The ladder is 5 yards. Okay, that's a long ladder. The distance from the bottom of the wall to the top of the ladder is 1 yard more than the distance from the bottom of the wall to the bottom of the ladder. Okay, so this part right here where it's saying bottom of the wall to top of the ladder, is it talking about this one or this one? The first one or the second one?
First one.
The first one, okay? So here it's giving us some sort of equation to use. But then we talk about the next one, and it says that more than the distance from the bottom of the wall to the bottom of the ladder. So this distance here at the bottom, okay, they don't give us any descriptor for that, so we need to assign it a variable. So what variable do you want to give it? What letter? D? T. T. Okay, T. Okay, we assigned it T. Now we can go back over here and look at this side, and it says that it is 1 yard more than the bottom. So how would I write that? T plus 1. Okay, does it matter what variable you assign these? No, unless it says use this variable. Okay, if it doesn't, you can use any. Let me erase that. I don't like that it's going to the side. Okay, so then we see here from our diagram that we have what type of triangle? A right triangle, which means we can use what formula? And what is that called? The Pythagorean theorem. Okay, so then for here, the only important value that we have to label is what? C. So this is C. The rest of them don't matter. So I can say A squared is T plus 1 squared. And B squared is just going to be T squared. And C squared is 5 squared. Okay, so when I get to this part, you should see this and say, okay, I need to take this and write it how many times? Twice. So I have T plus 1, T plus 1, plus T squared equals, what's 5 squared? 25. Okay, what am I going to do with those parentheses? Foil. So the first term goes into the parentheses, then the second term multiplies into the parentheses. So what is T times T?
T squared.
T squared. What is T times 1?
T.
T. Okay, now on the blue arrows. What is 1 times T? T. What is 1 times 1? 1. Bring everything else down. So plus t squared equals 25. Okay, I see a squared in there, which means it's quadratic. So I need to make sure the equation is equal to 0. So how do I do that? Move the 25 over. Okay, so I have t squared plus t plus 1 plus t squared minus 25 equals 0.
Can we take the initiative to change the interval?
And change the what?
The interval. He was messing with us, bro.
The variable?
The variable, yes.
You don't like t's?
Too much.
T's are very common, so in application problems, so you have to get used to it, sorry. Okay, so combine like terms. What terms are alike?
T squared.
The 2t squareds, and then what else?
Those two T's.
The t's, and what else?
Minus numbers.
The numbers, the 1 and the negative 25. So t squared plus t squared, 2t squared, t plus t, plus 2t, right? Because we're adding them together. And then 1 minus 25, negative 24 equals 0. Okay, what's the next step?
Can we do the
Before we do that, can we do something else?
Times 24.
Did you see it?
GCF, right? You can do 2 times negative 24, but you're just going to end up with larger numbers. So let's make it easier for us and take out a GCF. If possible, always take out a GCF. So if we take out a 2, what's left over?
T squared
T squared
plus t
plus t
minus 12.
minus 12, right, equals 0. And then this is a lot easier to factor than this is. Okay, so if we do a times c, what do we get?
That is
Negative 12. And what's our b value? 1, right? Because if we don't see a number in front of our variable, we know it's 1. So what two numbers multiply to negative 12 but add to 1? 3 and 4. Which one has to be negative? Well, which one? 3 or 4? 3, right? 3 has to be negative. Negative 3 times 4 gives us negative 12. Negative 3 plus 4 gives us positive 1. So if we made the mistake and switched them, we would have ended up with a negative 1 instead of a positive 1. Okay? So then I have t squared minus 3t plus 4t minus 12. And then bring down my GCF in the beginning, set it equal to 0. Now what? Factor by grouping. Okay, and then I have to take out a GCF. So what's the GCF of the first parenthesis? T. So I have t, and I'm left with t minus 3. And then the next one? 4, and I'm left with t minus 3. Okay, bring down my GCF of 2, set it equal to 0. Okay, what are my two parentheses here? T minus 3 and t plus 4. Bring down the GCF, set it equal to 0. Last step, equal them to 0. So t minus 3 equals 0. T plus 4 equals 0. So if I solve this one, I get t equals 3, and the next one is t equals negative 4. And since we're talking about distance, which one are we crossing out? Negative 4. So that means we have an answer of t equals 3 what? What's the units? Yards, but it wants to know both distances. So right here, we just found this one. We found this is 3 yards. How do we find the other one? We add 1. So then we have 4 yards. So our two answers are 4 yards and 3 yards. The 2 on the outside? Well, technically we set that equal to 0, but does that make sense? Can 2 equal 0? So we skip it. So it just goes
So
away.
anytime it's false, you just skip it.
Yeah. Honestly, even if it was, well, no, you'd never get true because you would never have a 0 GCF in the front. The only time you would get a number from this is if instead of 2, let's say you took out a 2t. Then it would be 2t equals 0, then t is equal to 0. Okay.